Hey, how's it going, guys? Lesson 2.3 notes today. This is day number 3 of our recording. Keep in mind, tomorrow, again, I don't know what the schedule looked like this week, but if you've been here every day, if you were here Tuesday, Wednesday, and Thursday, today would be Thursday, day 3. You're going over lesson 2.3 notes. So tomorrow will be a study hall in class. So make sure you're just you got all this done, ready for me, all the homework and everything done for me, ready on, that would be Monday when I come back. So looking at day number 3, 2.3 notes. This is we're kind of talking about solving quadratic functions, or solving quadratic equations, functions, whatever it may be that we kind of want to talk about. So what we've dealt with in the past is we have dealt with factoring. And again, you kind of know this. Make sure you have paper people. Make sure you pass out 2.3 notes. I try to make that a point. Obviously, stop the video anytime. Factor, but make sure you start it again to make sure you finish the notes. I want all this stuff done come Monday. We've talked about factoring quadratic expressions. We've dealt with that before. We've looked at factoring quadratic expressions. We dealt with that over when we went through our review of algebra. So we're kind of looking at that again. However, we're actually going to take it one step further. I'm going to say one step further. And we're going to take it to where we're actually solving quadratic functions, or solving quadratic functions or equations here. We could say equations. Okay, so we've dealt with factoring quadratic expressions. Now we're talking about solving quadratic functions or equations. And as you see, this has all been about, this whole week has been all about ax squared plus bx plus c form. F of x equals that. So this week it's all been about that standard form of a quadratic function, which is ax squared plus bx plus c. So let's jump into this. Let's take a step back and let's review our factoring quadratic expressions. So if we're looking at number 1, a couple different ways to factor this, but the one way that I've taught you that I refresh your memory with was change the lighting just a little bit. Okay. One way that I definitely talked with you about was grouping. So you multiply the first term by this last term. 1 times negative 10 would be negative 10. So again, that's that 1 here. So 1 times negative 10 is equal to negative 10. And then you're going to ask yourself, what two factors multiply to give you negative 10 but add to give you 3? There's only 2 factors. You got 1 and 10 and 2 and 5 of 10. So 1 and 10 won't add to give you 3, but 5 and 2 will. You just got to figure out which is which. So if you had positive 5 and negative 2, 5 minus 2 will add to give you 3, and 5 times negative 2 will also give you negative 10. So we can rewrite that as this. X squared, I'm going to put the 2 first, minus 2x plus 5x minus 10. And I really could have put either one first, but keep in mind, now watch this. 3x, we just changed it to negative 2x plus 5x. Negative 2x plus 5x still is 3x, so we haven't changed anything. And then we solve by grouping here. What can I factor out of x squared minus 2x? Well, there's a 1 and 2. I can't factor anything out there besides a 1. But I have x squared and x, so that means I can factor out an x here. So if I factor out an x here, if I pull an x out of x squared, I'm left with just x. If I pull an x out of negative 2x, I'm left with negative 2. And then I can pull a 5 and 10. 5 will go into 10, so I can pull a 5 out of 10. There is no x. I can't pull up x out of 10, so that x is just going to stay. So I can pull a 5 out. If I pull a 5 out of 5x, I'm just left with x. If I pull a 5 out of negative 10, I'm left with a negative 2. So then I have this right here. X minus 2 times x plus 5. So this comes there, and then x plus 5. And that would be our answer here. That is that quadratic expression factored. Okay? Look at number 2. A squared plus 7a plus 12. So again, multiply 1 and 12. So 1 times 12 is equal to 12. Now what two factors will multiply to give me 12 but then add to give me 7? Well, I would have 3 and 4. And both of them are going to be positive. Now if you can remember, anytime this is 1 right here, you actually don't even have to factor all this by grouping. You can actually just draw your parentheses like this and put an A on both of them. And then whatever you have here, just drop it in. So plus 3 and plus 4. And if you factored all that out, you would, or if you FOILed that out, first, outer, inner, last, you would see that you're going to get the same thing. But you really, and this just shows that it still works, but when you have a leading coefficient other than 1, that's when you have to factor by grouping. So this right here would be our answer for number 2. You know how to do that. So what we want to do is we want to take it just a step further. We want to actually solve for the equation by factoring. And what this is called is the zero product. The zero product rule is kind of what we're going to. If you can remember, we talked about zeros when we were dealing with, when we begin to deal with functions and quadratic functions, like x squared and stuff. I'd always ask you, what are the zeros? And I actually, at the time, I had you find the x-intercepts and the y-intercepts, but now we're going to transfer to getting away from those y-intercepts as being zeros, and our only true zeros we're really going to look at for a quadratic equation are going to be the x-intercepts. So basically, what we want to do here is we want to find the x-intercepts or find the zeros of it. And when you do that, you're essentially solving the equation. All right? So what you want to do is always set, if we're looking at this equation, n squared plus 5n equals negative 4. This is not in standard form of a quadratic function. Quadratic function needs to be ax squared plus bx equals, or plus c equals something, or equals f of x. So since we're using the zero product rule, we're actually going to move this. So it's n squared plus 5n, and we're going to add 4 to both sides. So add 4 to both sides. When you do that, well, that can't combine with anything, so it just simply becomes plus 4 over here, and negative 4 plus 4 over here is 0. We want this side right here to be 0. Okay. So our first step in this is to get 0 to one side, or get it in standard form, which is also to have 0 to one side. Have 0 to one side. All right. And then from there, so I have a guest right now. I have London Grace. London, can you say hello? She's a little wild. She just woke up. Say hi. I'm not sure what she's doing with her tongue. I didn't teach her that. Say hey. Say hello. You're pretty. Are you beautiful, London? Yeah, you are. You're very pretty. Okay, hey, that was brought to you by State Farm Insurance. State Farm will be there for you. I work for State Farm. I can't even remember the tag. Like a good neighbor, State Farm is there. That's what it is. Gotcha. All right, so that's just your brief entertainment for the day, seeing my beautiful daughter. N squared plus 5n plus 4 equals 0. So once we have it set to this, what we're actually going to do is just simply factor it from here. So we got 1 times 4, so bring 4 over here. So just kind of even ignore that 0. We're just getting it into standard form, and then we're going to factor it. N squared plus 5n plus 4. What two numbers multiply to give you 4 but add to give you 5? Well, that should be pretty simple, 4 and 1. Keep in line with what I just said. I just said if there's a 1 there, the only thing you have to do is say n, parentheses, and then make sure you put equals 0. because now this right here, we know both of those are positive, so they're just going to go straight in here. Plus 4 plus 1. But the difference in this, what we're doing here and what we're doing up here, is notice we have this equals 0 now. We've taken it from an expression to an equation. So we now have this, and normally this right here is where we would stop because that's that expression factored. But since we now have an equation equals 0, what we're going to look at there is what we want to do is we actually want to split this off, or you could say even separate it to where it looks like this. N plus 4 equals 0 and n plus 1 equals 0. This is the zero product rule, which says that if you have this both equal to 0, if this and this is equal to 0, then this equals 0 and this equals 0. And when we do that, then we can just solve each one. So subtract 4 from both sides, that cancels. N is equal to negative 4. Subtract 1 from this side, that cancels, and n is equal to negative 1. So our answers to this equation, I'm not going to put it into an xy, I'm not going to put it into a parentheses, we're going to put it into a brace and say negative 4, negative 1. And you can make fun of my braces, that's fine. And this is our answer. And you may be saying, well, what is that answer? If you plug this back in, negative 4 back in, it is what's going to work. If you plug in negative 1 will work into the equation. So we are solving each of these equations by factoring, but we're following this new zero product rule, which says once you get it to this factored form, if a times b is equal to 0, then a equals 0 and b equals 0. That is what the product rule is. So then we just split it up and we solve each one. And if we were to graph this, if we were to just taking it to another another level, if we were to go to y equals, and I was to graph x squared here, plus 5x plus 4, if I was to graph that right there and hit graph, I'm going to have my parabola. But what I want to show you, this whole zeros, if we go back to, hey, what are our zeros here? Notice we got negative 4 and negative 1. Well, if you scroll over here to find that right there, you're going to see a 0 there at negative 4. And if you scroll to the right here, you're going to see a 0 there of negative 1. Another way you could do that is just hit second trace, which is second count, and it says, oh, number 2 is 0, so you can just hit enter, and it's going to ask you the question, what x are you talking about? Well, I'm talking about this x right here. What is that x-intercept? We'll go left bound, go right bound. Oops, sorry. Got to redo it. 0, go left bound of the x-intercept you want, of the 0 you want, and go right bound and hit enter, and you're going to get negative 4. The same thing will work for negative 1. So essentially what we're doing is we're actually finding the 0 here. We're finding the zeros of and we're finding the x-intercepts, essentially. Okay? All right, let's go to number 4. So number 4, we need it, our first step, get it in standard form. Have a 0 to one side. So that means we need to subtract 4 from both sides. Now this time, 4 can be combined with that 19. So we got x squared minus 8x. 19 minus 4 would be positive 15. And then watch, over here it canceled or it gave us 0. That's what we want. Notice it's in this form, ax squared plus bx plus c form. So then once we're there, look at this. That leading coefficient is 1. That's a beautiful thing. Drop those x's. So because that means we don't have to really group. And then come over here and say, okay, 15. What two numbers multiply to give me 15 but will add to give me negative 8? Well, I have 1 and 15, 3 and 5. Okay, 3 and 5 sounds good. So let's look at 3 and 5. What would 3 need to be and what would 5 need to be in order to be negative 8? Well, if 3 is negative, negative 3 plus 5 won't get you there, but negative 3 and negative 5, negative 3 minus 5 is 8. Or excuse me, is negative 8, and negative 3 times negative 5 is 15. So we're going to say negative 3 and negative 5. I kind of went through that kind of fast, but we should know how to do this. So then once we get to this point, then we can just simply say these are equal to 0. So what we can say is x minus 3. Oh, no, I didn't mean to do that. X minus 3 equals 0, and x minus 5 is equal to 0. And then we just solve for both x's. So add 3 and add 3. X equals 3. And add 5 there. Add 5 there. That cancels. X equals 5. So our solutions to this equation, this quadratic equation, is x equals 3 and x equals 5. Now, if you're sitting there saying like, man, this is just too much, I don't get it. Hey, just keep in mind, go back to solving equations in 8th grade or 7th grade or wherever you were solving equations. In 6th grade, you were solving equations. But you didn't have this squared, okay? So that brings on a whole new element of things. So you're still solving it, but this is the path in which you solve it. You solve it by factoring, and then once you get here, your answers are 3 and 5, which are also your x-intercepts. Let's do 2 more, and then I'll call it a day for today. So let's look at number 5, going to number 5. So the first thing I need to do is I need to get it in standard form, which is to have 0 to one side. So I need to subtract this 3 right here. I have to subtract that 3 in order to get this side to 0 in order to get like terms here. So now I have 2n squared plus 7n minus 15 equals 0. And now that I have that, I'm going to, unfortunately here, so look, I don't have that leading coefficient of 1, so that means I'm going to have to factor by grouping. So 2 times negative 15, bring it up here. 2 times negative 15 is negative 30. So now I have to ask myself this question. What will multiply to give me negative 30? What 2 factors will multiply to give me negative 30 but add to give me 7? Well, 1 and 30, 2 and 15, no, 3 and 10. 3 and 10 can combine, hopefully, somehow to give us 7. So what would what would 3 and 10 have to be in order for it to be 7? Well, that would be a positive 10 and a negative 3. Negative 3 times 10 is negative 30, but negative 3 plus 10 is positive 7. So I'm going to rewrite 7n as 2n squared. I'm going to put the 10 first just because 2 goes into 10 and 3 goes into 15. 2n squared plus 10n minus 3n minus 15 equals 0. Okay, now that we have that, what we can now say is, okay, let's factor by grouping. So again, 7n just was rewritten as this right here, so we didn't change anything about the equation, we just rewrote it. So now we can factor 2 and 10, they have a common factor of 2, so we can pull a 2 out. N squared and n have a common factor of n, and then, so I can pull a 2n out of this, and if I pull a 2n out of 2n squared, I'm left with n. If I pull a 2n out of 10n, 10n divided by 2n is 5, n plus 5. Here, negative 3 and negative 15 have a common factor of negative 3. N has no common factor, so it's just going to be a pull a negative 3 out. So when we pull a negative 3 out, we're going to be left with, pull a negative 3 from negative 3n, we're going to be left with n. Pull a negative 3 from negative 15, you're going to be left with positive 5 equals 0. So now we rewrite this. We've done this. We've practiced this as this. 2n minus 3 and n plus 5 equals 0. Now, we're used to putting the brakes on right there and saying, okay, we're done. We're good. All right? But this is where we're taking it, as I mentioned at the introduction, we're taking it one step further by saying now we're actually solving this. We're actually saying this is the answer to this equation. These are the ends. So I'm going to rewrite it as this right here, as, or I'm just going to rewrite the whole thing as 2n minus 3 and n plus 5. Now, following the zero product rule, the zero product rule is if a times b is equal to 0, then a equals 0 and b equals 0. So technically we can say this. 2n minus 3 equals 0, and n plus 5 equals 0. And then we just solve both equations from there. So add 3 to both sides. That cancels. 2n is then equal to 3. Divide both sides by 2. And you get n is equal to 3/2. And then here, subtract 5. You all know how to solve equations. N equals -5. So my answer then here would be 3/2, comma 5. Or excuse me, -5. And this right here would be my answer. Hope this is making sense, okay? I hope this is kind of making some sense to you guys. There's that. You can kind of look at it for a second. If you need to pause it, feel free to pause, okay? Last one. And I know it's, or I'm assuming it's chapel day, so I know our time is a little bit limited. So we'll just look at 6 here. And then I think you're more comfortable then. Again, the only thing you're doing is you're just taking it one step from this right here and just setting them both equal to 0 because they're equations now and you're solving. So this should be, we should be pretty decent with this. All right, looking at 3x squared minus 8x minus 6. Let me straighten the paper out for you. First thing I'm going to do is to, again, that first step, get it into standard form where you have a 0 to one side. So we're going to add 3 to both sides. When we do that, we get 3x squared minus 8x. Negative 6 plus 3 would be -3, and then that equals 0. Let's multiply 3 times -3. Now we're ready to factor. So you can kind of forget about that 0 and just factor as if it's normal. 3 times -3 is -9. What will multiply to give me -9, but then add to give me -8? Well, that should be just 9 and 1, and then -9 plus 1 would give us -8. So I rewrite this, and again, you know how to do this, or you should know how to. If not, you need to talk to me or get some help within that. 3x squared, and I'm going to say minus 9x plus x minus 3, and that all equals 0. So from there, we're going to factor by grouping. So we have 3 and negative 9 have a common factor of 3. And x squared and x have a common factor of just x. So if I pull a 3x out of 3x squared, I'm just simply left with x. If I pull a 3x out of negative 9x, I'm left with a minus 3. There's nothing common over here besides a 1, so when you don't have anything in common, you just pull out a 1, and here would be a positive 1. If I pull a positive 1 out of that, that's just going to leave me just x minus 3. Anytime you pull a 1 out, it's just going to be the same thing. And that equals 0. So then we have 3x plus 1 times x minus 3 equals 0. Now I'm going to take it to the side, and I'm going to say 3x plus 1... and x minus 3 equals 0. And then I can rewrite, based on the zero product rule, if AB is equal to 0, then A is equal to 0, and B is equal to 0. So 3x plus 1 is equal to 0, and x minus 3 is equal to 0. Subtract 1 from both sides for that. That cancels. Give you just a second, just in case you get caught up. Sorry, I may go too fast. And I get 3x is equal to -1. Divide both sides by 3. X equals -1/3. Add 3 to both sides, and I get x is equal to 3. So I have brace -1/3, comma 3. And I know my braces are embarrassing. Hey, I hope this has been a great week for you all. That actually concludes it. Again, tomorrow, if tomorrow is Friday, again, I don't know what the schedule looks like. I don't know if you guys are going to miss any snow due to, I don't know if you all have already missed any snow due to, or school due to snow. I said miss any snow. But Friday, of course, would be a study hall. So you're making sure all this work that I've given you this week is done. Hey, have a good week. Have a good weekend. And again, I don't know what day this is. I assume it's Thursday. Have a good chapel, whatever it may be. Thanks so much. Have a good day.